Thanks for giving me the opportunity to be the first of these lightning talks here. Climate change is having a range of different impacts on our forest ecosystems. These impacts are going to be on individual trees through increases in growth or changes in growth, changes in mortality. There's going to be shifts in the amount of stresses that our forest ecosystems are experiencing through things such as drought, as well as changes in the frequency and severity of large-scale disturbances such as wildfire that we're talking about today. Now, one of the frameworks that we can use for actually trying to deal with these climate-induced changes is thinking if we can use climate-adaptive silviculture solutions to mitigate some of the negative impacts that climate change is expected to have on our forest systems. And this can involve a range of different things. Some of them can be changes in our harvest strategies, in our management strategies, which will actually induce near-term shifts in climate risks. Other things, such as planting future climate-adaptive species, are looking over a much longer horizon to try to make sure that our future forests are going to be climate-adaptive. Now, this is all great. These are things that we should be thinking about in terms of preparing our forests for future climate scenarios. But a critical aspect of this is trying to understand how these climate-adaptive silviculture solutions may influence this really near-term risk that we have of wildfire, which is the whole framework of what our project is looking at, trying to evaluate how these climate-adaptive silviculture solutions will influence fuel loading, fire risk, microclimate conditions. Now, our project is working in the central interior of BC here, in the subboreal spruce zone, which you can see in that nice pink color there. And it's actually part of a much larger project, the Adaptive Silviculture for Climate Change project, which is an international project that has 14 different network sites throughout North America, 2 in Canada. We're the most northern site, Powder-Wawa Research Forest being the other research site. And what this network is designed to do is to use a common, rigorous scientific framework to test how adaptive silviculture may mitigate climate change impacts. And what we can do in this project specifically is try to leverage some of the learning that we're getting from these very different forest systems, very different climatic systems, to try to understand how this influences this big thing of fire risk. Now, the exact site that we're using is in the John Prince Research Forest, which is in the SPS there. The John Prince Research Forest is really quite unique with regard to research forests because ever since its inception in 1999, it has been co-managed by the Clasden, Binche-Wootton, Nikaslii-Wootton First Nations in combination with UNBC. So it really is a community-directed, community-led research forest where the type of adaptive silviculture strategies we're using really grow out of the objectives that the community has for that forest. Now, within this adaptive silviculture for climate change framework, we're basically testing different silviculture strategies that can be used to mitigate climate impacts. And this goes from fairly light touches to really quite heavy touches. So on the light side, we have our resistance treatments, which are asking the question, can we modify forest structure so it's going to be more resistant to climate change? So the fairly light touches, not big shifts in forest structure. The intermediate would be modifying forests so they're more resilient. So this is a little bit more allowing some changes in the forest structure, forest ecosystem that will make it more resilient to things such as wildfire. And then on the kind of more extreme side is transition. So this is where we really are thinking about big shifts, intensive big shifts in our forests that are going to make them more pre-adaptive to the type of climate futures we expect in the future. And for each of these different treatments, we're looking at a range of things: timber production, biodiversity, wildlife, some of the benefits we get from wildlife, and critically, what this actually means for wildfire risk as measured through changes in fuel loading, changes in microsite conditions, changes in just our risk potential. I've mentioned that this is being done at the John Prince Research Forest here. Again, kind of see an overview of where the John Prince Research Forest is. What I'd like to highlight is this is the actual outline of our treatments that we put in. And there's a couple of things I'd like to just leave you with. One is that the planning for this research started in 2019. The harvests were done in the winter 21-22. And we've been following how these stands have been developing since that time. And through this project, we're going to continue that for the next 3 years. So we get this temporal analysis of how these stands are changing with regard to fire risk from year 1 after harvest to year 7. So really building in how these stands are changing through time. The other thing that I'll just highlight with this slide here is that although this is a very rigorous kind of scientifically designed treatments, it is operational forestry. We're doing everything just using operational approaches, and it's on a fairly big scale. So within the experiment, we have 5 treatments going from this no touch to kind of really heavy pushes. And we've got 4 replicates of each, with each replicate being a 10-hectare area. So not massive by any means in terms of forestry scales, but enough that we can actually get landscape variation, ask questions about when we are doing this type of operational level forestry, what does it mean for fire risk in a scientifically replicated framework? Now, I won't go through what the actual silviculture strategies are that we designed for each of these treatments. This is just an example of some of the kind of high-level overviews that we have for our resilience treatments. I think these slide decks will be available for you, so please look through this. If you have any questions in future, reach out to me. I'll just point out here that for the resilience, some of the key factors that we're looking at is the silviculture was designed to increase species diversity, specifically favoring broadleaf species on the environment, increase the vigor of those trees that we're relying, and really reduce ladder fuels and the fire risk that we have in the stand. So these are kind of the near-term impacts. Also, doing some adaptive planting where we're taking southern provenances of some of our common species, Douglas fir, spruce, lodgepole pine, putting them into our sites and seeing how they're doing in the future. For our project, these are the 5 different objectives that we're ostensibly hitting. I'm not going to go through them at all, but again, if you look through them in the future, if you have any questions, by all means, reach out to us. We'd be very happy to chat. What I will say is more interesting on this slide is a picture of our field crews that are out in our plots this summer. This was one of our resilience treatments. The crews measuring overstory canopy structure, coarse woody debris, fine woody debris loading, as well as microsite conditions. And what I'll leave you with is that we're just starting to get some of the initial data coming in here. If you do have any questions about what we're doing, what our adaptive silviculture treatments are actually looking like, some of the data that we're collecting, please feel free to reach out to us. We'd be very happy to talk with you, possibly collaborate with you based on the data that we're having and these large-scale landscape level experiments that we're running. So thank you.